Hey everybody, this is Mr. Munson, and we're looking at factoring is the basic idea that we're going to be doing. Today we're looking at factoring 1.0, if you will, the very first idea, basics of working with expressions and equations. Very simple stuff, just kind of setting the standard of what you need to know in order to move forward into the little bit more thought-provoking stuff of factoring. Let's get started. I'm not sure if you've ever noticed this, but when you were doing Algebra 1, there was a typical pattern to the way that they dealt with different kinds of problems. They would start you off with expressions, and these expressions are things that would be no equal sign involved in them, okay? So it might be, things like that. And those are expressions. And then they talked about how to manipulate them, combine like terms. And so you could take something like that and move it to being something a little bit simpler, like maybe 7x plus 6. Then they moved you from that world into the world of equations, and all of a sudden the directions went from simplify to solve or find x or whatever it might have been. And so it's typical, you deal with a certain type of expression, then it would move into working that expression in a world of an equation, and that's pretty much how it played out if you think back at it. So, if you want to, take a few seconds, see if you can solve this equation. All right, and there you have it. X is equal to negative 1/7. And all that's saying is if I take that x and I stick it into this equation, that the left side will look like 5. Okay? Doesn't look like that. Did I make some kind of mistake? Let me look back at my mathematics here and check it. Yep, that certainly works. All right, so I just wanted to kind of remind you of that basic kind of flow of how you work with. So if we wanted to find the total area of this multiple figured shape here, we'd need to know the dimensions. So I don't know, let's say this was 3x, 3 times some number gives me that length. And of course, if that side's 3x, this side's 3x in this particular figure, okay? So let's say this is, plus some length of 5, okay, whatever that would be, okay? Now we know that if this is 5 at the top here, then it's 5 down at the bottom of that blue shape. Let's suppose this is, we're going to add, it's a different length, so we're going to say 4, okay? Now, if we look at these shapes, we can take those expressions and multiply them out to find the area. Remember, it's length times width equals, that shape for polygons. For parallelograms. So, I'd have to take something like this and multiply it. Now, that could be somewhat of a trouble for some people if they've never had algebra. Let's just kind of do it in steps first. So I'm going to look at the yellow, and of course it's 3x times 3x. It gives me 9x. And then that 3x belongs over on this side as well. So I can make this red one 15x. And then the green one down at the bottom has a 3x for its top, so that gives me 12x down there. And then the blue one, the final blue one down there has a side of 4 and a side of 5, so that's 20. So the total area of this thing is 9x squared plus 15x plus 12x plus 20. Let's simplify that, put the common terms together, and we get something like this, okay? Make sure you understand that before we go on. So basically we found the area of each little piece by multiplying the length and the width of each little piece. Now according to this this expression at the top, if I take the side and the top and multiply it together, I should get that exact same kind of expression, which would calculate the area of this thing. Well, that doesn't necessarily look like something I can do unless I know FOIL. So FOIL is you multiply the first, then you multiply the outers, then you multiply the inners, and then you multiply the last. Okay? And I like to draw it that way. One reason is because it looks like a monkey's face. Okay, so I'm going to go ahead and do that in that order, and we'll see what we get. So, of course, first, our 3x times 3x. The outer is going to be 3x times 4, which is 12x, plus the inner, which is 5 times 3x, which is 15x, and then the last, which is going to be 20. And you can already see where we're headed on this. Okay, so I could multiply the things. I could set up a complicated figure like the thing on the left-hand side and multiply the pieces and then put them together, or I could just simply understand FOIL and take the long side and take the height and the width and multiply them together using FOIL. Okay. So hopefully most of this is just, review for you. Combining like terms, simplify, we definitely should have that one as 9, right? I'm taking 5 ones and 4 ones, and I'm adding them together, and I have 9 ones, or $9, or 9, or whatever. Okay? So on this particular one, I cannot add together anything. There's nothing that goes together. It's 5 x's and 4 ones, two different things. So I have like 5 x's sitting around someplace, and then I have 4 ones sitting around, and I can't combine them together and say I have, 9 x's. That's not what it would be. So the simplified form is what it is, right? All right, let's move up to this one. So I've got 5x and 4x. That's equal to 9x. This is all probably very trivial. Let's take a look at this one. Make sure you know how to do this one. I'm going to pause just for a second, let you check it. All right, and there you go. So nothing else can be combined together. Listen, the standard is you put the variables with like x's and y's and z's first, and then you put the constants, the numbers, at the end, like 3. Put the letters in alphabetical order if it makes sense. Sometimes it makes more sense to put if something's negative inside the numbers, not at the leading thing. All those kind of things. Just get really used to looking for a logic and a reason to how to order these numbers. Here's some more basic stuff, distributive property, and we're just going to send this through and make it equal, or I should say equivalent, okay? So that all becomes, after I send that through, it becomes 15x plus 20y plus 30. And I'll just check to see if there's any like terms. There's not. I have x's, y's, and numbers, and that doesn't do anything different. All right, go ahead and do your hand at this one. I always encourage you, especially if you struggle in math, to do the visual effect of drawing the arrows to help you understand and keep track of what you're doing. Go ahead and do that one. Put me on pause and come back and check your answer. All right, there we have it. Check your answer. If there's anything about that you're not sure of, then certainly come and see me after school. But basically, we know that when we're multiplying x times x, you get an x squared, and those kind of things. So analyze that, make sure you understand how to do it. And there's this one. Let's look at dividing quantities. So the thing on top is a quantity, okay? It's 3x, and the 6 is tied to it by addition, okay? So what I would encourage you to do is see that as one big block of numbers that are tied together, okay? So you can't just take the 3 and divide it into one part of that. It's got to be divided into both parts of it. So you can do that visually in your head. 3x divided by 3 plus 6 divided by 3. Pretty small terms there. You could break it up so it looks like this now. Whatever you need to do, right? So it becomes x plus 2, which is definitely a lot simpler than that. Now take a look at this. This problem is a lot different than the one above. It has all the exact same characters typed up. And so what I want you to understand is this is saying I have 3x plus 6 divided by 3. Okay? Now if the writer of this wants you to actually take 3x plus 6 and divide that whole quantity by 3, the writer should do something like that. Or write it where it's very obvious that everything is being divided. Okay? So sometimes, I might get careless typing something up on a test. If you see something like this and you believe Mr. Munson probably meant parentheses, don't assume that. Just call me over and say, Mr. Munson, should there be parentheses around this? And then we can have a little discussion about that. So now we're looking at a little bit more different stuff here. We're looking at quantity times a quantity. Okay, so when you have a quantity times a quantity, I want to teach you a basic way of multiplying things like this, but I want you to understand foiling. Foiling is important because I want your brain to start thinking in terms of foiling, because when we go to factor, factoring is just foiling in reverse. It's like x squared, squaring something, and square rooting something are opposites of each other. Foiling and factoring are opposites of each other. So let me show you a way of just multiplying these two quantities in a certain way, and then I'm going to show you something with foiling. So we're going to take the quantity out front and multiply it times the things inside. We're going to distribute that. So just use, take a look at that and see if you can identify the colors and how they played out, okay? So I have that 2r plus 12y there, and I'm just going to take the thing out in front, 3x plus 4, and multiply it times 2r. And then I'm going to take that 3x plus 4 and multiply it times the 12y. Just like if the 3x plus 4 had been just a simple number 5, I could have sent that 5 through and multiplied everything inside by that 5. But in this case, it looks like it's going to be a bigger problem, and it's really not. All you got to do is set it up like that. Now I'm going to distribute in our normal way. So I'm going to use my arrows to give my visual impression of what I need to do. I just need to distribute that through. All right, so I distribute it through. Put me on pause. If you don't have that, or if you didn't write it down, stop me and look at what I did and make sure you understand. Let your brain have a chance to think that through. I like to go through and coordinate which things have the same terms. So I don't see any RXs anywhere. I see an R but not an RX. There's no other XYs and no other Ys. So that's pretty much the order in which things are going to play out there. Okay, so I just leave it in that simplest term. So why don't you try your distributive property here with this x plus 3 and x plus 2. Don't worry about foiling it. That's where we're going to go. But right now, I just want you to practice this just using the distributive property. Put me on pause and come back and check. All right, so there I have it set up. And I'm just going to, again, distribute the pieces again. What I want to do is I want you to see that when I did the x plus 3, I put parentheses around it. Because it's a quantity, it all is owned by itself, right? The x and the 3 are contained together. And so if I dropped off the parentheses, it would look like x plus 3 times x. So be careful, make sure you have the parentheses in the right. All right, so I just put some visual clues to help me identify what are like terms. Let's put things together. And there's a simplified version of that. Okay, so if I give you something like that and ask you to simplify it, I want it written out, expressed that way. Yeah, I might actually give you this kind of stuff later on and ask you to factor it and make it look like these two things that are multiplied together. By the way, I want you to know, if there is such a thing, this is my favorite trinomial. Trinomial being three-termed expression. All right, let's just take one last quick look at FOIL and then we'll be done. Okay, go ahead and do this one on your own. First, outer, inner, last. Draw it out, have it the same way every single time. Your hand will do it on its own. There's my monkey face. Go ahead and express that out using first, outer, inner, last. You already know what it's going to be. It should look like that, so you know the answer. Check your ability to do FOIL. So I like to put up there so I can put each term underneath each place and put pluses and minuses in between them as I. So it's all neatly laid out. Combine my like terms. And I have myself a trinomial. My favorite trinomial, needless to say. All right, have your hand at this one. There you have it. And hopefully you're catching this on. What's happening? What happens is this outer and inner two numbers always seem to combine together to give me that middle term. Keep that in mind because that's going to help you factor later on. Okay, same kind of process, just bigger and more numbers. But go ahead and check your hand on this one. And there I have it. Hey, now one of the things that you can do if you're, you know, a little bit iffy about your answer, you can, in order to check to see if you've changed an expression around to, you know, into some new kind of version. So here I have two expressions that are two binomials that are being multiplied. And I've multiplied them out and I created these two trinomials. To check it, what I could do is just simply take any x. Let's try 2, and we'll plug it into this one, and we'll plug it in this one, see if we get the same number. So I just plugged 2 into that expression, evaluated what this guy would be and what this guy would be, and 7 times 13, which is 91. So then I went down and plugged 2 into this expression, and sure enough, 91. That tells me I've done my simplification correctly. All right, there you have it. Some pretty simple try it problems. Really no reason to turn in a green sheet next time. I bet you even if you've just stumbled into the try it section here, you can do these problems. All right, make sure you get 100% on that. See you next time.